This is a Sparton AC62 radio from 1927. This is a TRF set, but it's also an earlier AC powered set. Kind of like this. This is actually metal, painted metal, but it's very believable as wood. It's kind of interesting. A nice loud power switch. Volume control. Unfortunately, the tuning control is non-functioning. I have to fix that. Looking at this just like a generic AC powered radio, but actually on the inside it's a bit more interesting. So first off, we've got a power box over here, the power supply. Got a receiver chassis in the middle, and the box on the right there is the filter chokes and filter capacitors. And start with the rectifier. Let's see if I can get this out here. That's the rectifier uses. It's a Raytheon BH tube, and this is a cold cathode rectifier. You can see up there. So the way I understand how this works is it works based on the ionization of gas. So these two, inside these two ceramic things here, are the cathodes, and this big metal dome on top is the anode. And this is filled with gas, and when there's a high positive voltage on the anode, then the electrons, the gas between the cathode and the anode ionizes, and the electrons can flow from the cathode to the anode. But when the polarity is reversed, the electrons can't flow backward. And I imagine the way that that works is probably there's a pointy tip on the end of each cathode, and when you have a pointy tip like that, it's much easier to ionize than when you have a flat, a smooth surface like the anode here. So probably the way this works is because the cathode has a pointy tip on the end. I mean, you can't really see, but I'm just imagining that's what's in there. Has a pointy tip on the end. That allows for easy ionization, and the electrons flow from the cathode to the anode. When the polarity is reversed, because the anode is smooth, it's much harder for it to ionize, to flow backwards. So that provides the rectification function. And there's two cathodes, which just means it's a full wave rectification. So the second interesting thing about this set, put this off to the side, are the receiving tubes. So let's see if I can pull one of these out here. You'll notice that there are wires going to either side of the tube, and that's actually the filament connection. Only 3 of the pins on the bottom are used. One's for the grid, one's for the anode, and one's for the indirectly heated cathode. And the fourth one is not used. I'm not sure the order, just that's 3 of them are that, and the fourth one is not used. I'm not sure which is which though. And then the 2 on the side are for the filament connection, and these are 3-volt tubes. And the way I understand, these particular ones are pretty much the same as type 27 tubes with just different connections and a 3-volt filament. And these are type 401. I'm not sure if you can see that on the top or not. The original type 401 actually had these connections on the top here, had a little cap with the 2 pins on for the filament connections, and that was a bit different. That had it was a bit different structure on the inside. But I think these ones with the filament connections down here are pretty much the same as the type 27 tubes. So probably what I'm going to do first is figure out how to get this out of the cabinet and take a look at the tuning mechanism, and probably see about what kind of capacitors, because I know that with the Raytheon BH rectifier, there are 2 capacitors right off the power transformer. So if I decide to power this up, I'll probably change those right away first, just so that I don't short the transformer out. I know that on the RCA Radiola radios, the paper filter capacitors are pretty stable and don't really short out. I'm not sure about the capacitors on these Spartan ones, if they're the same kind or not. But see if I can get this out of the cabinet and we'll go from there. So I got everything out of the cabinet. I took this middle piece out first, which is kind of difficult to get out, so probably it would be better to take the two boxes out first and then take this out, but oh well, I got everything out. When I put it back in, I'll probably put this in first and then put the two boxes on either side. So the first thing I'm going to do is what I like to do on all these old 1920s radios is check all the big coils, the big inductor coils, like the audio transformer and power transformer and chokes and everything, for continuity, because these old large iron core inductors like to go open a lot of the time. So I'm going to start by checking those, and if all those check out okay, I'll see about fixing this tuning mechanism, and then we'll see about maybe replacing one or two caps and go from there. Okay, so you can see our four tuning condensers up there, and they're all tied together by the dial string, which has come loose. This is like a braided, either copper or steel or something wire, braided, and we're just soldered together, and the solder's broken, so I'm going to have to see if I can fix that. These big barrels here are 0.5 microfarad capacitors. See on the schematic, one of them right there and the other one right there. And so we're going to start by checking these two audio transformers. Probably while I'm in here I'll check these resistors too. That's this big long resistor, and here is a big long strip of resistance wire. Probably check that. This is a capacitor over here as well, and that might get replaced. These barrel looking things in here and down here, those, well, some of them are resistors. It looks like the other ones might be inductors. I'll have to see. If you look at the schematic here, it has this little, that might be what this thing is in parallel with another inductor. I'll have to check that out, make sure all those are good. And then up in the audio circuit we have a resistor here and here, and that's the grid leak resistor. That's probably what these guys are, these resistors here. So we'll start by checking these. The primary of the first one goes from the plate of this tube to the 2 meg resistor, which I believe goes to the B+. Yes. So, see if we can get the meter in here. So we kind of see that. Let's see if we go from here to up here. We have something. 9K. Alright. Let's check the other side. $3 meg. Wait a minute. That can't be right. So it looks like the other side, yeah, that should be a 0.25. So it has the coil in parallel with a 0.25 meg resistor. So why because it's showing us 3 megs. I'm checking the right thing. Be that and that. I'll have to check this out closer. So it took me a while to realize, but actually these are labeled plate B+, ground, and filament minus. So this would be one side, and this would be the other side. Actually, this would be the primary, and this would be the secondary. So let's see if we go down in here and check this. We've got 2K on the primary. It's going to be hard to. I'm not going to be able to see that. I'm not sure this is going to work. And about 9K on the secondary. So this one seems okay. Can go over to the other one here. It's labeled grid. I'm just going to tap off the grid on this tube. This is connected to the transformer down there. It's hard to reach. And we've got our about 8K on the secondary. And let's see if I can. And 2K on the primary. So those transformers check out alright. Probably next I'll move on to the chokes. Oh, and by the way, I did take out the resistors in parallel. These little socketed resistors go into sockets like that. You can check these too. These usually drift. See if I can get on here. See what this one checks out at. Come on. Maybe. This thing is so difficult. $172K looks like. 172K, and it's supposed to be 0.2 megs, which would be 200K, so it's kind of close. It'll probably work. I'm sure these radios were designed for wider tolerances and resistor values. Of course, I don't even know what the rated tolerance would be on something like that. This is 400 on 406 meg. For 6 meg, it's rated at 1/4 meg, so again, kind of close. It'll probably work. So now on to check the filter chokes. I actually decided to do the power transformer next, so we can just take out 4 screws, 2 on each side, and get that out of the bin. So this should just lift out. Looks like they had this shield around the tube like that. Okay, so we have our special rectifier. Put that off to the side before it gets damaged. Have our nice large power transformer and the filter capacitor. That will probably have to go. Look at the way this is wired here. So you can see we have the power transformer here. That's the special no cathode, or cold cathode rather, rectifier. And you can see they have the 0.1 and a 0.1 there. That would be this guy here, this capacitor. And see, that's directly across the secondary of the transformer. So normally, in a regular hot cathode rectifier power supply, like when they use a type 80 tube or something, they have the rectifier and they have all the filter capacitors and chokes and everything after it. So if you get a short on one of those capacitors, there's a good chance it'll take out the rectifier before it takes out the power transformer. But in this case, these are before the rectifier. So if one of these has a short, or I guess both of them would have to have a short, if they have a short in here, it would take out the power transformer pretty quick probably. So I'm probably just going to replace that just for safety before I power this up. And then as far as what we're checking, we're going to check continuity in the primary and then the 3 secondary sections. So these two are for the 3 volt filaments. Let's get on here. Let's see the meter. And that looks good. And we'll check the 5 volt filament windings here. And that looks good. So then, looks like we should be able to check on either side of the rectifier socket. So let's see which. Oh. That's probably charging the capacitor. That's charging the capacitor. And that's nothing. Okay. That looks good. 500K for the high voltage winding. That looks good. So then, what's left? I need to check the primary. So theoretically, if I turn the switch on and then just check across the plug, that should give us some indication. Just stick my probes in here. Well, that doesn't look exactly promising. Could be that the power switch is bad. See where these go. There and there. That 10 ohms, I believe that. That might be okay. I wonder if the switch is bad then. So that's with the switch off, nothing. And that's with the switch on, also nothing. Alright, I'll have to take a look at that. So that's probably the problem, then the switch was not operating correctly. It might just be dirty. But the power transformer looks good. So I'll move on to the filter chokes. And if the filter chokes check out okay, then I'll be replacing this and reattaching the dial cord before I try and power this up. Looks like it comes apart the same way. I'm taking the nuts out, so let's see if we can get this out of here. Okay, so it looks like we've got a resistor there and 3 chokes. This is probably where all the capacitors are in there, so that's going to be fun to redo. Alright, so I'm just going to go through and check continuity on these and see what happens. So it turns out that almost every section in this big resistor here has been open. I managed to reconnect this one at the end, and then this one I just put a resistor in here and resistors in here too, since I couldn't get these to reconnect. And then I cut the wire here. This is just a coil of resistance wire. I cut this here so that there's no way that this can accidentally reconnect and then throw the resistance off. So the way that I've been figuring out what resistance to put in, because there's no values given here for any of these on the resistance strip, is I just take my 2 probes and I kind of rub them along until I find where a break is. You can see that. Let's say 500K. $800K. So I'm basically at the ends there, so I'll just replace that with a what, 800 ohms. I'll just replace that with a 1K. This one here was in multiple different sections, so like from here to here I got like 400 or something, and then from here to here I got like 1.1 or what was it? It was, anyway, whatever it ended up being. Maybe it was in 3 sections. I just put, it ended up being the total I calculated was about 1.7K. So I got a 1.5K in series with a 200 ohm. And this is just the cathode resistor. Here, this whole thing. So it goes to the cathode of the tube for grid biasing, so there shouldn't be a whole lot of current flowing in there. This is a 1 watt resistor, this is a 1/4 watt, that should certainly be sufficient. There should only be, maybe like 10 milliamps or something flowing through that, and just a couple volts drop across it. So that should be no problem. So I'll stick a 1K in here, and I've got one last little section over here that I'll probably figure out the same way. And then once I get that done, then I'll go on to working on the dial. I did check all the chokes in the other box there with the chokes in it, and they all checked out fine. So hopefully we can get this resistor done, and then hopefully get the dial working again. That's one more thing I wanted to mention when you do this. These are usually enamel coated, so you can either try and scratch away the enamel bar with the multimeter over it, or just use some fine grit sandpaper to lightly sand the enamel off so that your probes can make good contact when you slide them across there. So I got the dial working again. This and this are both attached to a pot metal bracket in the back here. And the pot metal bracket screws into the top bakelite thing and also into this front bakelite thing. And it has a shaft that comes out that this rides on, and it has a hole that this shaft goes into. And I don't know exactly what happened, whether the shaft that this was on sunk back into the pot metal bracket or what exactly, but when this screw was tightened all the way down, this was completely unmovable. So what I did is I just put a couple lumps of solder in the back here so that when you tighten the screw down, it doesn't go all the way against and squash this dial against the back of the bracket. I also had to repair the dial string. This was broken. There's actually 4 separate tuning capacitors, and they're all wired together with the dial string. And it was broken right here. So what I did is there's two screws. There's one on the back of this drum here. There's one that the cord wraps around, and there's another one that tightens down to lock it, sort of. And then there's also a set screw that screws into the screw that the cord wraps around. So I loosened everything and pulled this out a little bit so that I could overlap this and this one. And then I took some of this real fine gauge wire and wrapped it around the overlap to sort of hold them together so that I could solder everything together. And now, let me turn this. See all the tuning capacitors turned together. I'm not sure if it's by design or just kind of happened, but it seems like when you get up further on this end of the dial, it has more of like a veneer drive, or the other end rather. So this end now when I turn it, it seems like it's going faster. When I turn up on the other end, see, it almost seems like it gets a veneer drive sort of there, like it slows down a little bit. I don't know. Anyway, it works, so we'll leave it like that. In order to get at this, since you can't take the front plate off, I had to take this bakelite or Formica piece completely off of the rest of the chassis there. And to do that, there was 3 screws on either side, and then I had to take these brackets off the audio transformers and also take the screws out of that big long resistor. And then this just comes right out of the chassis. So that's the front. So to put it back in, I would flip this around and kind of, yeah, it's gonna, I'll have to get that back in there, but something like that, go back in. So we'll put that back in. Probably then I'm going to replace the capacitors and hook it back up, and so yeah. Okay, so I got this thing finally back together. When I went to put it back together, originally, the dial was pushed so far into this faceplate that it wouldn't turn again. So I just backed it up maybe an 1/8 of an inch or so, and then drilled new holes and put the screws in there. So the only thing I can think is that somehow that pot metal piece, I guess the back, like the back behind where, so like this dial thing rides on a shaft that sticks out the front of the pot metal piece. So the only thing I can think of is the back of it where the shaft protrudes from must have like come forward or something, which both pinched the dial against the screw head at the end of the shaft and pushed it into this faceplate here. That was the only thing I can think of anyway. But we got it back together, and now we can tune stations, hopefully. I also did replace the capacitors inside of here. These guys over here. So we had 2.05s, or no 2.5s. This is a kind of interesting one. It's just like a big barrel, and it looks like they tacked the contacts on the end. Here's the other one. This one came off. It's just like a plate that they tacked on the end of the foil there. And we had a 1 microfarad. This is what was in that red box under the chassis. And this is a different kind of wax too. Usually they're like a yellow wax, but this is a white wax. Not sure what kind of wax that is. Anyway, so next I'm going to replace the capacitors in the filter choke and power transformer box, and I guess after that we can try power up and see what we get. Okay, so I got the Spartan all back together. You can really see in there all the tubes. All the tubes are populated. So we'll get a high impedance speaker, and we'll do a channel sweep since it's night now to pick up lots of stations. We'll see how that good the sensitivity is. Back in the day, they would have just closed this lid and set the speaker on top, but I'm not going to do that. I don't like to run these operating with the lid closed because you can see the bone marks. Oops. You can see the bone marks here from all the tubes with the lid closed, so I like to leave the lid open when I'm operating these. So I'll just set the speaker in front here, and we'll do a channel sweep in the dark. Okay, so I got my high impedance speaker in the front here, got the radio hooked up, just have a long piece of wire going back and forth across the ceiling for an antenna. Since this is a TRF set, it's not going to perform as well as a super heterodyne, so it uses the antenna to pick up basically anything. So I'll turn off the lights and do a channel sweep. Warms up, you can get some good glow in the 75 output tube. The 75 output tube and the dial light are both 5 volt, and the rest of the tubes are all 3 volt. And the 3 volt ones, the funny looking ones with the filament connections on the side, take quite a bit longer to warm up. See how we're doing here. That looks warmed up, so volume and start our channel sweep. Something pretty faint.
Let's get a pat on the back for. Oh, wow, you were ahead of everybody. Go ahead.
Is not equipped to do the job. When he lashed out at Kim Jong-un and said he wasn't...
Patreon.com
Clyde Lewis. We had the CD available for Christmas. People sending in their donations for that. Appropriately named, joining us today on 1290 and 610. The story of America and the story of business are so intertwined is in fact because.
Well, you're married now to a beautiful.
The title of most admired man in the country.
And again, spending will pick up quite a bit.
You're talking about
Television broadcasting the game tonight. Chris Connor, and also an empty netter for Phil Baroni to seal the deal, and a wonderful performance. Out of the way. And I think that ball spilled over his forearm to the outside. I think this is going to be
Where should that go on the 75 to?
The play is now under replay review. Lorenzo Joe coming back to the football just in front of the stakes. He was beyond the stakes, but he's got to take the angle away from Sparks, true freshman cornerback,
YouTube don't blow quite as
who's
great.
really become a player over the second half of the season. But I believe, Bill, that we're going to get a reversal on this call.
For the Irons and Telephone Allentown Indoor Race Friday and Saturday, January 5th and 6th. Top drivers from throughout the Northeast.
Second and 10 from the 38, and this is an incomplete pass. Once again, this is an officiating crew out of the Pac-12. Mark Duddy, the voice you'll hear once they have a decision. Tom Herman's first year. That was an interesting story, David. He said in our conference call with him when he was at Ohio State. He said Urban Meyer really didn't want.
There it is, the 1927 Sparton AC62. Up and playing again. There's much frustration with the dial getting stuck, but here it is, it does work. So hope you enjoyed this video, and thank you for watching.